A cornerstone of modern cosmology is the realization that not only is our universe expanding, but it's expanding at an accelerating rate. While much is still unknown about what's causing this, there are a few theories as to what it could mean for the fate of all things, the end of the universe. And according to one theory, the very fabric of time and space could one day be destroyed because of it. This is Unveiled, and today we're answering the extraordinary question, is the universe tearing itself apart?
Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more fascinating content?
For thousands of years, the universe was believed to be stagnant and unchanging. Sure, the planets had their orbits around the stars and the moons had their orbits around their planets, but that was as far as it went. It was believed that galaxies and the distances between galaxies never changed, and that the wider universe had remained the same since the dawn of time. It wasn't until Isaac Newton formulated his laws of gravity that this fundamental belief was really called into question. In light of Newton's new laws of nature, a stagnant universe made no sense. If all objects had mass, which Newton showed they did, then the gravity of that mass should have been causing the universe to collapse in on itself. This obviously hasn't happened. So what was it that was preventing gravity from doing its job? The phenomenon went mostly unexplained until the year 1929, when, by studying the red shifts of distant galaxies, the famed astronomer Edwin Hubble discovered that everything in the universe was in fact moving away from us. For the first time in history, we had evidence that the universe was expanding, which posed another new theory, that it must have been this way since the beginning, since what came to be known as the Big Bang. However, at this stage, we knew nothing of the expansion accelerating, and so it was assumed that the internal mass of the universe would still eventually cause expansion to slow down and presumably even hit reverse. This belief that the universe would one day contract back towards its ultimate demise came to be known as the Big Crunch theory. All known evidence indicated that this view could well be the true view of the nature of the universe, up until the year 1998. Then, two separate studies discovered one of the biggest surprises in all of modern physics. The Supernova Cosmology Project and the High Z Supernova Search Team were both charged with observing the light from Type 1a supernovae, which are supernovae specifically occurring in binary star systems where one of the stars is a white dwarf. Both projects had expected to observe that the supernovae would be moving away from us at a decreasing rate, meaning that expansion was slowing down. But what they actually discovered was that the pace was increasing, and we've known since then that expansion is accelerating. It was a moment in time that completely changed our understanding of how the universe works, and it prompted yet more questions. Most notably, why wasn't gravity slowing expansion? Physicists came to the conclusion that there must be some unknown energy actively working against it. This inexplicable force is now known as dark energy. While most everything about dark energy is still unknown, scientists have calculated that it must be responsible for 68% of the universe's matter-energy composition. For comparison, dark matter is thought to make up 27%, and all visible matter, all the stars, planets, and moons, only make up about 5% of the universe. Besides the fact that it exists, the very little we can say about dark energy is almost entirely theoretical. The problem is that it's only indirectly observable, meaning we can only examine the way it interacts with gravity and visible matter, and there's not yet a physical way for us to examine it directly. Nevertheless, most of the evidence we have indicates that, unlike matter and radiation, for example, dark energy is uniform throughout the universe. It doesn't dramatically shift or change in density as new space is created. Instead, it's an intrinsic property of space itself. And this base understanding has allowed physicists to theorize three possible fates for our universe. If the energy density is in fact a constant, then the universe will simply continue to expand at a steadily increasing rate, culminating in what's known as a big freeze. Eventually, cosmic distances would measure towards infinity, and only objects that are gravitationally bound to each other would remain linked in any way. New stars would no longer form, and all existing stars would begin to die out. After trillions of years, only black holes would remain, before they too would disappear, according to Stephen Hawking's radiation theory. The Big Freeze gets its name because all that would be left of the universe is a cold and empty void. But what happens if the density of dark energy isn't a constant? Scientists can't rule out that there could be slight variations in how dark energy works and how much of the universe is comprised of it. In fact, early observations do suggest that dark energy may be either slightly increasing or slightly decreasing in strength. If it decreases enough, then we're back to a big crunch scenario, where things return inwards. But if it increases in strength, then it's thought that the force of dark energy could become so strong that the fabric of space-time itself would be under threat and could even tear apart. This is the Big Rip scenario, and it's potentially terrible news for, well, everything. In this scenario, dark energy overcomes all other forces of nature, including gravity. Whole groups of galaxies are pulled and stretched across the universe. In the Milky Way, we'd first see the star systems on the outer arms break off, but nothing would truly be safe. Eventually, the Big Rip would reach as far as our solar system, relatively central to the Milky Way, pulling it into the abyss to drift through the cosmos all on its own. And then even the solar system would shatter as dark energy becomes too powerful. The planets would one by one be ripped from their orbits, and then they too would be singularly destroyed. According to some models, the strength of dark energy could continue to grow to an infinite degree, so that planets, creatures, plants would all be pulled apart. And then the atoms themselves would split into their subatomic parts, which in turn would eventually disintegrate. Besides dark energy, the universe would again be left as an empty void. It's just that this time, it will have taken an incredibly violent path to get there. Unfortunately, because there is a suggestion that dark energy may be either increasing or decreasing in strength, scientists can't yet rule out that the universe is ripping itself apart. And many confidently claim that it's beyond doubt. The Big Rip is happening. Fortunately, however, according to most current predictions, if the Big Rip is to occur, then it won't be at least for another 80 billion years from now. That's almost 20 times as long as the Earth has existed for. And what's more good news is that it's thought that it would take around 10 billion years before the first even slightly noticeable effects of this incredible phenomenon would take hold. So rest assured that you're not about to be torn apart today, tomorrow, or next week. It's a problem for your very, very, very distant descendants to work out. But for now, you're safe. Of course, the fate of the universe remains an ongoing question for science regardless. And whatever happens to it, we're increasingly confident that dark energy will play a large part. Luckily, the coming years will see a number of next-generation telescopes put into action. And these could trigger a new age of cosmological enlightenment as we begin to unravel the secrets of dark energy. The first of these telescopes, Euclid, is set to launch anytime before December 2022 and will be able to measure the redshift of galaxies and therefore the density of dark energy with all new levels of accuracy. Still, if the universe really is ripping itself open, then there will likely never be anything we can do to stop it from happening. It would be nice to know what the future holds though, wouldn't it? And that's why the universe might be tearing itself apart.
What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.